All right. Good morning. This is going to be for Friday. I heard that y'all had those state tests going on the last couple days, so welcome back to actual math content. Um, that said, let's go ahead and get into it. So today we're going to be doing solving systems of equations by elimination with two variables. Hopefully this is at least somewhat familiar. You've seen this more or less in integrated 2. Because eventually we're going to start doing 3 variables, but for now, today's just going to be a review day. So if you remember that or you pick that up pretty quickly, this will be pretty easy. So let's go ahead and get into it. Oh, that said, I did grade all the tests. Okay, I graded the tests, and also I'm within the next couple days, I'm going to go through and I'm going to mark as complete the grading for test 1 and test 2. So that means if you haven't taken one of the first 2 tests yet, it's going to get input as a 0 until you take it. So again, that's to pressure you to take it. But anyways, everything that I have is now graded for integrated 3. Okay, so if you have any questions, please ask me. If you want to do retakes, that would be great. But as a whole, I was definitely happy with the integrated 3 tests. I did notice a couple that were blank. If you want to retake, please do that. I also had a few that left the back page blank, even a few that did really well on the front page, but then left the back page completely blank. And if that is you and you are just finding out that there was a back page, please go ahead and retake, or just retake the back page even, so that way I can fix your grade. All right, so we've got a few different cases. As we look at on this the other page, it says opposite coefficients, same coefficients, and multiples of each other. All right, so that actually applies. These first 2 examples are going to be examples for when we have opposite coefficients. The next 2 examples are going to be for when we have the same coefficients, and then the last 2 are multiples of each other. Okay, so we'll see what that means. All right, and the nice thing is this is actually in order that you want to look when you're starting to solve these problems. The first thing we're going to look for in elimination is, do we have any coefficients that are opposite? And when we say opposite, that's got to be with the same letters. Okay, like for example, on number 1 here, I notice I have opposite coefficients. We're talking about between the 2 equations. All right, so I've got a plus 5y and a minus 5y. All right, those are opposite coefficients and they've got to be on the same letter. Also, if this was like a 17 and a negative 17, that doesn't count. Coefficients need to be attached to a variable. All right, so notice we've got a plus 5y and a minus 5y. Those are what we call opposite coefficients. Okay, so write this down. When we have opposite coefficients right off the bat, all you're going to do is go ahead and add those equations together. So we're going to go ahead and add those equations. So that gives us 8x. And then notice negative 5y, or 5y minus 5y. That eliminates the y's. That's the idea. We're trying to eliminate one of the variables. And then we're adding this up. 17 minus 9 gives us 8. All right, and then we can solve for x. So we'll divide by 8 on both sides. And we will get x equals 1. Okay, but we need to solve for x and we need to solve for y. So what we can do is we just take that value that we just got for x, go ahead, plug it back in. It does not matter which equation you plug it into. I'll just plug it into the top one. So instead of 2x, that's going to be 2 times 1, because x is 1, plus 5y equals 17. All right. And then from here, I'm going to go sit at a table. This is hard to do. Okay, so that's 2 times 1 is 2, so we can go ahead and simplify that. And we've got 2 plus 5y equals 17, and then we can just go ahead and solve for y. So I'll subtract the 2 on both sides, and I get 5y equals 15, and then divide by 5, and you'll get y equals 3. All right, we got another example of the same thing. All right, so again, we're looking for opposite coefficients. All right, so first of all, this is not opposite coefficients, right? We've got a negative 3 and a positive 3, but one of them is on a y and one of them is on an x. So if you see something like that, that does not count. However, if we're looking at the x's, we do have opposite coefficients, so we can proceed. I just want to point that out because if you see something that appears to be opposite, but they're not on the same letter, that is not considered opposite coefficients, and we can't and you're not going to want to immediately add the equations together. Okay, but anyways, in this case we do because the x's have opposites. So we're going to go ahead, add these together. So if I'm adding these up, negative 3 plus 3, that will cancel. Negative 3y minus 4y is negative 7y, and 9 and 5 is 14. And then to solve for y, we'll divide both sides by negative 7, and you'll get y equals negative 2. All right, and once again, we're going to go ahead, plug it back into one of our equations. It does not matter which one we plug it into. I'll just plug it into the top one. So I'll get negative 3x minus 3, and then instead of y, I'm going to replace that y with a negative 2, and then equals 9. All right, so we got negative 3x, and then negative 3 times negative 2, if I'm evaluating this right here, that is a positive 6. And then I can subtract my 6 from both sides. I'll get negative 3x equals 3, and then I can divide by negative 3, and I will get x equals negative 1. All right, so the moral of the story, this is the first type of elimination problem, is when you see those opposite coefficients right off the bat, go ahead and add the equations together, because then you're going to be able to solve for one of the variables immediately. And as soon as you solve for one, you plug it back in to get the other one. All right, case number 2. If you're going through these and you see that we have the same coefficients, all right, so if we're looking at example number 1 right here, example number 1, we see that we've got the same coefficients between the top equation and the bottom equation on the y variable. All right, so we can go ahead and subtract those equations. All right, so opposites you're going to add. If you see the same coefficients, you are going to subtract. All right, so let's subtract these equations. But notice, if we're subtracting, though, we are subtracting everything. It's like you're going to distribute that negative sign. So that's going to be a minus 9x, a minus 2y, and a minus 22. You can also think of it as multiplying one of the equations all the way through by negative 1. You're just switching all the signs. All right, so let's go ahead and subtract these. Well, 5x minus 9x, negative 4x. And then this is the key step. You'll get that 2y minus 2y, and that is going to eliminate the y variable. That's the goal there, right? We're eliminating that one variable. 6 minus 22 gives us negative 16, and now it's a one-step equation to solve for x. So we'll divide by negative 4, divide by negative 4, and you will get x equals 4. All right, and then as always, same thing when we do an elimination or substitution, anything with systems of equations, we got to plug that back in. And again, it does not matter which one you plug it into. I'm just going to plug it into the first one. You just pick one. So I'll get 5x. But again, notice I'm going to substitute it in for x, right? Because x is 4. And then plus 2y equals 6. All right, 5 times 4 is 20. Plus 2y equals 6. And then we're going to subtract the 20 on both sides. And you're going to get 2y equals negative 14. And divide by 2. And you're going to get y equals negative 7. All right, one more example just like that. So again, first thing you look for is, do we have any of the opposite coefficients? No, we don't. But do we have any of the same coefficients? Yes, we do. Because looking at those x's, once again, this time it's the x's that are the same. They both have 2's. All right, so if it's the same, you are going to subtract. All right, so let's go ahead and subtract. So if I'm going to subtract, remember, that's like multiplying by negative 1. So you're just going to switch all the signs here. Switch all the signs. A minus, that becomes a plus. That becomes a plus. All right, and now we can just add them together. So we got 2x minus 2x. That one is eliminated. Negative 5y plus 7y, that is a 2y. Negative 6 plus 14, that is an 8. And once again, we've eliminated a variable. That's the goal. We've eliminated our x's. So we've got 2y equals 8. We're going to divide both sides by 2. And you are going to get y equals 4. All right. Once again, let's go ahead, plug that in, get our x. So we've got, instead of 2x, that's going to be no, sorry, it is 2x. We're plugging in for y here because we solved for y. So 2x minus 5, instead of y, we're going to substitute that 4 that we just found for y, equals negative 6. And then 5 times 4 is 20. And we can go ahead, add 20 to both sides. And then negative 6 plus 20 is 14. 2x equals 14, so let's divide by 2. And you'll get x equals 7. All right, so those are like our easier cases, all right? So if we have the opposites, we can just add the equations together. If we look through our two equations and we see some coefficients that are the same, we can just we can subtract the equations. Or you can think about it as multiply one of them by -1, or switch all the signs and then add them, however you prefer to think about it. Case number 3 is we have none of the above. It's a little bit trickier that way. All right, so we need to find a way to force there to be multiples of each other. Okay, so sometimes it's a little bit easier than others, sometimes it's not. But what we're going to have to do is we're going to have to go through and multiply one or maybe even both of the equations by a certain number. All right, but again, the idea is that we want to make it to where we have one of the first two cases. So we want to make it to where our coefficients are opposites or to where our coefficients are the same. So what I notice here is I have a 4y and a 2y. These would be pretty easy to get to have the same coefficient, right? Because if I multiply that bottom equation by 2 on both sides, it's going to give me a 4y. And then we're going to have that case where we've got the same coefficients, and then we can proceed from there. All right, so what I'm going to do is I'm going to take this equation and I'm going to multiply the entire thing through by 2. So let's see what that does. Let's copy the top one down because we're not changing that. 3x plus 4y equals 6. And if I multiply that bottom one by 2 on both sides, look what's going to happen. I'm going to get a 10x plus 4y equals negative 8. All right, notice I took this equation, multiplied it by 2, and it gave me that one. All right, so now we've got coefficients that are the same, and now we know what to do. All right, when our coefficients are the same, you switch all the signs or subtract them, however you want to think about it. So what I would do, I'm going to go through, switch all of our signs, and then we can add. All right, so that 10x is a negative 10x. That 4y is a negative 4y. And then that 8 or negative 8 becomes a positive 8. All right, so now we can go through and add these equations together, right? Because what we've done is we've made it to where that now we can eliminate one of the variables. So we got 3x minus 10x is going to be negative 7x. 4y minus 4y, that's our key right there. See what we did? We eliminated the y. And then 6 plus 8 is 14. All right, and then once again, we can go ahead, solve for x. Divide by negative 7 on both sides, and you'll get x equals negative 2. All right, and again, it does not matter which equation we plug it into. I'll go ahead, plug it back into this first one from the very beginning, because we still need to solve for y. So we're going to have 3 times negative 2 plus 4y equals 6. 3 times negative 2 is negative 6. Then we can add the 6 on both sides. We'll get 4y equals 12. Divide both sides by the 4. And you will get y equals 3. All right, so when we don't have, what we're seeing is when we don't have the same coefficient or the opposite coefficient, there's that one extra step we've got to do at the beginning, is we've got to multiply through by a certain number to either the top or bottom equation, such that it ends up giving us a new set of equations where we've got same coefficients. Okay, this last example, this is going to be the trickiest type. All right, it's when we don't have an immediate way of getting same or opposite coefficients. All right, so is right. I can't, if I, no matter what number I multiply this bottom equation by, unless I do a fraction, it's not going to end up giving me either the same or opposite coefficients as the top equation. All right, and when that happens, you could multiply it by a fraction. However, I think it would be a little bit faster and possibly easier, because you just generally want to avoid fractions when we can, is to go ahead and multiply both equations by a certain number. All right. Now that number does not have to be the same number. In fact, it shouldn't be the same number because that won't get you anywhere. But all that matters is that you're multiplying by the same thing on both sides of the equation. And there's more than one way to do this. One trick is that you could do opposites. So whatever variable you want to eliminate, you could do it this way. So suppose I want to eliminate the y's. All right, it doesn't matter which one. This one has a coefficient of 4. So I'm going to multiply the bottom equation by 4. And this one has a coefficient of 3 or negative 3 on the y. So I'm going to multiply the entire top equation by negative 3. Okay, so this is one way of doing it, because watch what happens when I do that. I'm going to write the top equation first. So I'm going to write this one right here. Negative 3 times 3x is negative 9x. Negative 3 times 4y is negative 12y. Negative 3 times negative 25 is going to be 75. All right, now I'm going to do this bottom one. So 2x times 4 is 8x. 4 times negative 3y is negative 12y. 4 times 6 is 24. All right, and then now what we need to do is notice that now we have the same coefficients. All right, so now we can go ahead and switch our coefficients here. So we can switch them. This is back looking at case number 2, right, where we have the same coefficients. So if I want to make, I could go ahead and multiply my top one by negative 1. So I can make that a plus 9x, a plus 12y, and a minus 75. All right, and if we want to add these together now, right, what's going to happen is we're going to eliminate the y's. So we've got 9x and 8x, that's 17x. 12y minus 12y, that eliminates. And then negative 75 plus 24 is negative 51. All right, divide the 17 out on both sides, and you're going to get x equals negative 3. And then, as always, we're going to go ahead, plug that back in, and solve for y. I'll plug it into the bottom one this time. So we're going to have 2x, so that's 2 times negative 3 minus 3y equals 6. 2 times negative 3 is negative 6. Minus 3y equals 6. Add our 6 on both sides. You'll get negative 3y equals 6 plus 6 is 12. And then we can divide by negative 3. And you're going to get y equals negative 4. Okay, so remember, we've got 3 different cases here. We're either going to have opposite coefficients, we're going to have the same, or it's going to be neither one. So if it's opposite coefficients, that's our easy case. We're going to go ahead and add those equations together. Some variables automatically going to get eliminated, and then you can solve for one and then plug in or substitute to find the second one. Case number 2, they're the same. Multiply one of the equations by negative 1, so think you're switching all the signs, and then that will eliminate one variable, and then you can plug in to get the other one. The third case is the tricky one. Those are the multiples. You're going to have to multiply one equation or maybe even both equations all the way through by a certain number. And you want to pick a number such that one of your coefficients, either the x coefficients will line up or the y coefficients will line up. So that way we can eliminate one of those two. All right. Let me know if you have any questions, and good luck on the worksheet.